Hello, welcome to video number 57. It's just me today. Actually, it's you and me, so there are two of us. Um, in this video, we're going to go over the solutions to the homework quiz we had in class this week. We want to make sure we understand these problems and kind of retaining what we learned in the past. Okay, so here we go. The first problem was based on Jenny, who was 4 foot 11 inches tall. It says she's 4 foot 11 and wondering about her height. The heights of girls in the school are approximately normally distributed, with a mean of 5 foot 3 and a standard deviation of 2.6. What is the percentile rank of Jenny's height? Okay, so the first question is, what do they want? They want to know what percent of people, or girls actually, are below Jenny in height. Okay, so we should start by drawing a normal curve. So this is a normal distribution problem. And my curve's kind of goofy, but it'll work. On average, the girls are 5 foot 3. You know, we have to realize that we have to convert this to inches. 5 foot 3, we have a problem with two different units going on here, is 63 inches. So the average height is 63 inches. Okay, and the standard deviation is 2.6 inches. Okay, and she is 4 foot 11 tall, so she's below the mean. 4 foot 11 is 59 inches. Okay, so she's 59 inches here. And we want to know what percent is below her. So just a little reminder, 4 feet and 11 inches is not equal to 4.11 inches. 4 feet 11 inches is actually 4 and 11/12 feet. So it's actually very close to 5 feet. But 4.11 is not close to 5. Okay, so remember, it doesn't work that way. You can't change 4 feet 11 inches to 4.11. Okay, so now we're going to do normal CDF. And the lower limit, something really crazy, big and negative, negative 100,000. The upper limit is going to be 59. The mean, mu, is 63, and the standard deviation, 2.6. And when you do all of that, you see that she is the 6.19th percentile, or almost the 6th percentile. Okay, so that's the answer. There's 6.19% people below her height. Okay, all right, next one. Okay, this one is exactly from the book, I believe. So the mean and standard deviation of a normally distributed data set are 19 and 4 respectively. 19 subtracted from every term, and then the result is divided by 4. Which one of the following describes the result of the distribution? Well, we start with a mean equal to 19, and standard deviation equal to 4. And when we subtract 19 from the data set, we get something that has mean 0, but the same standard deviation. Remember, standard deviation doesn't change when we subtract from the data set. Okay? Then we divide everything by 4. Well, the mean gets divided by 4, so it remains 0, and the standard deviation gets divided by 4, so it becomes 1. Okay, so that eliminates everything but 2 answers. So it can't be that one, and it can't be that one. It's either A or D. Now, there's something else going on here. If the data was originally had a normal distribution, after we subtract 19 and divide by 4, we do get mean 0, standard deviation 1, but the new data set still has a normal shape. So the correct answer is D. In fact, if we subtract the mean and divide by the standard deviation, we get the standard normal distribution. Okay, so A was good, but not quite good enough. The best answer is D. All right, here we go. This problem was changed just slightly from the homework. It says, which of the following is or are true? Median is resistant to data values. That means it's not affected by, the median is resistant to extreme values. That means it's not affected by extreme values. Well, that's true. The median isn't affected. So whatever the median is, you can make the max or the min as small or big as you want. It doesn't change the median. The mean is resistant to extreme values. That's false. The mean is influenced by outliers. So that's not true. The IQR is resistant to extreme values. That's true also. So if we have a data set, remember the IQR is the width of the box in a box plot, we can make this max as big as we want, but that's not going to affect the width of the box here, Q1 and Q3. So these are true. 1 and 3 are true. And that's why we use median and IQR when the data is skewed or there are outliers. It's because they're not really affected by it. They're resistant to extreme values. So the answer is E. Okay, this is all old stuff. We just got to keep fresh. One of the values in the normal distribution is 47 and its z-score is 1.7. If the mean of the distribution is 35, what is the standard deviation of the distribution? Okay, so one of the values in the normal distribution is 47. All right, well, this is about z-scores, and we know that z is equal to the data value minus the mean. You can use either x bar, or since we're talking about something as a normal distribution, mu, divided by the standard deviation. Okay, so let's fill in what we know. The z-score is 1.7. The data value is 47. The mean is 35. And the standard deviation is what we don't know. Okay, so let's simplify this a little bit. 1.7 equals 12 over sigma. If we cross multiply, we get 1.7 sigma equals 12, or sigma is, I believe, 7.06. Or if you said 7, that was close enough for me. All right, so this is just finding a missing value in this formula. All right, next. Okay, 5. We're getting there. There was only 6 questions. So 5, suppose that being in the top 10% of people with high blood pressure level is considered dangerous. Okay, assume that cholesterol levels are approximately normally distributed with mean 185 and standard deviation 25. Okay, so, whoops, didn't mean to do that. So let's draw this. There, that's what I meant to do. So here we go. Here's the distribution of blood cholesterol level. It's centered around 185. Standard deviation is 25. And you're in danger if you're in the top 10%. Okay, and we want to know how high could your blood pressure be without being in the top 10%. So we're asking for a cutoff value. Now, we know that 10% is to the right, but we got to think about how much is to the left. So there's 90% to the left. So we use inverse normal. And the area, instead of 0.1, we have to use 0.9. Remember, inverse normal only deals with area to the left of a value. So this will give me the area or the value that has 90% to its left. The mean is 185 and the standard deviation is 25. Many people got this one. So if you do that, you get 217. All right, so if your blood pressure or cholesterol level is below 217, you're avoiding that dangerous top 10%. Right, last question was a two-parter. These are actually copied directly from the homework. It says here are the salaries in millions of the Golden State Warriors. So someone makes 6.2 million. 0.3 million on the other extreme is about 300,000. Still not bad. Which gives a better picture of these salaries, a mean or median-based statistics? Well, first off, I'll give you the book's answer. The book says either one because the median and the mean are about the same. So if you enter those in the calculator, you find that the mean and median are almost equal. So the book said, well, it doesn't matter. Usually in the AP stats, though, if the data is fairly symmetrical, you see it's not perfectly symmetrical, but from here to here, that distance, about the same as that distance. So this is pretty symmetrical. We use the mean and the standard deviation. So because it's symmetrical. or symmetric. So use mean-based statistics, which means the mean and the standard deviation. Okay, so this decision is based on whether there are outliers or the data is skewed. If there are outliers or the data is skewed, you're going to use median-based statistics. If it's fairly symmetrical, you're going to use the mean. All right, now, Eric Dampier was the highest paid player at $6.2 million. What sort of raise would he need so that his salary would be an outlier? So he's already the max, but he's not quite an outlier yet, apparently. So we don't know how much more money would he have to have in order to be an outlier. So we need to compute the upper fence. So we can tell exactly. Remember, the upper fence is the third quartile plus 1.5 times the IQR. So if you enter that in your calculator, you find that the third quartile is 4.9 and the IQR is 2.6. If you do that, that gives you 8.8 million. So 8.8. And remember, our units are millions. If you gave me that as an answer, I accepted it, but it really said what sort of raise. To answer the question precisely, you got to tell me how much more he has to make. So 8.8 is what he needs. Subtract the 6.2, which he already makes. That leaves $2.6 million for a raise. Okay, I would like that kind of raise. I wouldn't mind being an outlier for CPS. All right, here's the last step. As always, here's a journal assignment. So these problems aren't going to go away. And so hopefully you go back and take a look at your homework quiz. You may not have gotten it back yet, but when you do, go back, take a look at it. And here are 3 very, very similar questions. And like I said, we want to keep going over these until we feel really comfortable about it. We got it mastered. I can ask you out of the blue any of these things, and you totally have it. That's how we're going to help ourselves get a really good grade on the AP test. So the first one is very much like the first question. The average height of girls in Rosie's school is 5'4" with a standard deviation of 1.9. Rosie's 5'2". Find her percentile rank. Then the next 2 questions are like question 6 from the quiz. Here are the points for the Chicago Bulls players for the last game against the Rockets. So first, decide whether we should use the mean and standard deviation or median and IQR. And then for question 3, Gasol was the guy with 27 points. How many more points would he have needed to have in order to be an outlier? Okay, go for it.